Okay, when they talk about equivalent rational expressions, we always relate it back to fractions. How do we come up with equivalent fractions? Well, for instance, 2/3. If I was to come up with an equivalent fraction to 2/3, I could multiply top and bottom by any number we want. I'm just going to pick one. You pick one. How about 7? 7/7. 7/7, that equals 1. When we multiply anything by 1, we don't change its value. Top times top, 2 times 7, that's 14. Bottom times bottom, 3 times 7, that's 21. 2/3 of 14/21. They're different values. They're equivalent expressions. Different numbers, but they have the same value. Another way I could do it is if I had a fraction like 10 over, let's see here, 30. Equivalent fraction, I could reduce the fraction. Okay, if you recall, if I factor the top, I could have 2 times 5. I express the numerator as a product of common factors. And the bottom would be 3 times 2 times 5, product of prime numbers. You do this in your head a lot. I'm just putting it down on the board here. Then we cancel out common factors, top and bottom. I have a 2 in the top and a 2 in the bottom. 5 in the top and a 5 in the bottom. And all that would leave me with is, in the top I always have, at least have a 1, and then the bottom 1/3. 10/30 is equivalent to 1/3. Different numbers, but they have the same value. Well, we can do the same thing with equivalent rational expressions. It's an infinite number of possibilities we could come up with. 20xy over 8x squared. You could put it on pause and see if you can come up with one on your own, and then I'll do one. Now how about this? I'm going to multiply top and bottom by, you know what? I'll use a y squared over y squared. They have the same top and bottom, same numerator and same denominator. It's equivalent to 1. Haven't changed the value. Top times top. 20xy times y squared. If you recall our exponent laws, y times y squared, y cubed. And bottom times bottom, 8 times x squared times y squared. There we go. We got ourselves an equivalent rational expression. Or I could have simplified this one. 20xy over 8x squared. Well, 20/8, what does that reduce to? I think you could take out a 4 from both of them. That reduces to 5/2. 5 and 2. And I have an x in the top and an x and 2 x's in the bottom, x squared. 5 can cancel them out. They're being multiplied. On top, one on the bottom. X. And I still have a y in the top as well. We've got ourselves an equivalent expression. The first one, we multiply top and bottom by a common entity. And in the bottom, we took out a common factor from top and bottom. Okay, so now that we know what a rational expression is, and we knew how to come up with equivalent expressions, and we now know how to find the non-permissible values, just like we simplify fractions from 4/6 to 2/3, we can simplify rational expressions, come up with a rational expression that's equivalent to this one, but in its simplest form. I'll put this on a note as well, and I'll send it out to you, and you can work with it. To simplify, how would I approach this? Well, first thing I do is I'd factor all the numerators and all the denominators. Okay? In the same way that we cancel out common factors in top and bottom in fractions, we're going to cancel out common factors in top and bottom of rational expressions. So x squared plus 6x plus 8 divided by x squared minus 4. I'm going to factor the numerator and the denominator, the top one. That factors out to x plus 4 times x plus 2. We factored it like we did in the past. And the bottom one, the denominator, that's a difference of squares. I'm going to factor that. X minus 2, x plus 2. binomials that are being multiplied, top and bottom, and two binomials being multiplied top or in the bottom here. Now my next thing I do is identify my non-permissible values. Any number that when substituting x would make the denominator equal 0. So I look at this binomial. What would I have to put into x to make this bracket equal 0? I'd have to put a 2 in here, because 2 minus 2 would give us a 0 in there. 0 times that other bracket would be 0. So I would say x cannot equal positive 2, or, and from this binomial, what would I have to put into this x to make this bracket equal 0? Negative 2, because negative 2 plus 2 would give me a 0 in here, or negative 2. Those numbers are non-permissible. We're not allowed to substitute them into x. They would give us a 0 in the denominator. And then the last part here, cancel out common factors in the numerator and denominator, like we would when we reduce fractions. Is anything common top and bottom? We have an x plus 2 in the top and an x plus 2 in the bottom. These entities are being multiplied. So I can cancel out 1 in the top, 1 in the bottom, and all that leaves me with is the x plus 4 in the top and the x minus 2 in the bottom. This at the bottom here is equivalent to what we started with. But we also take into account the values that we're not allowed to substitute into x into the original expression here. So that should help you as you start to work through your simplifying expressions. Always factor and then cancel. Factor, find your non-permissible values, and then cancel out common factors top and bottom.